Hello, welcome back. So today we are going to start something really awesome and new. Okay, the respiratory system. Now, before we start with the respiratory disorders and medications and all those stuff, something basic I want you to understand. Very important that you understand this. That is ABGs or arterial blood gas. Okay. Now, I know many of you are really good with ABGs. Like I gave you some numbers and you can really like tell me what kind of acidosis, alkalosis, whatever it is. Again, some of you may not be that much familiar. Okay. If you were like me when I was a student, I was scared, very scared of ABGs. All I will do was like get the report, give it to the respiratory therapist so they can talk. She can talk to the doctor. Okay. So, but I learned. Okay, and I kind of learned in an kind of figured out an easy way, and that's what I'm going to teach you today. Okay, and I don't know if you will see this in any books or anything. I'm not sure, but this is how I figured it out, and it works for me, and I think it's going to work for you too. Okay, so are you ready? I want you to have a pen and a pencil, or a paper and a pen, or a paper and pencil, something, or something where you can write, because I want you to do this in writing with me. Then only you will learn. And I'm telling you, if you stay with me for the next half an hour or 40 minutes or so when we have this lecture, by the end of it, you will be able to tell me everything about ABG. If I give you some numbers, you will be able to tell me if it is a respiratory acidosis or respiratory alkalosis or metabolic acidosis or metabolic alkalosis or compensated, either partially compensated, or uncompensated. You will be able to tell me, provided you are going to stay with me and listen to me and do what I say. Are you ready? Good. Okay, let's do this together. Okay. Now, just some overview about arterial blood gas. It's a measurement in the blood, right? That measures the acidity or the pH level, and also the oxygen and carbon dioxide levels. Okay. Now, with these ABGs, the main things we are really looking at, or we are really concerned about, is these three things. Okay, whenever you get an ABG values, like something like a blood values report, and where you have to figure out what's going on, these are the three things I want you to focus on. One is pH. Okay, the second one is bicarbonate. It will be denoted as HCO3, which is your bicarbonate. And the third one is PCO2, or partial pressure of carbon dioxide. Okay, so carbon dioxide, bicarbonate, and pH. These are the three things I want you to know to figure out what kind of acidosis, alkalosis, or whatever it is. Okay. Now, something else I want you to understand or remember. Carbon dioxide, we are going to consider carbon dioxide as an acid. And it's true. You know why? Because carbon dioxide is the gas form of carbonic acid. So it is really an acid, right? It's just that it's in the gas form. That's when we call it as carbon dioxide, right? So what is it actually? It's an acid. So we are going to consider carbon dioxide as an acid for this pH ABG interpretation stuff, okay? All right, for the ABG interpretation, for us, okay, for you guys who are the members of AppleRN coaching, okay, you are going to consider carbon dioxide while interpreting ABG as an acid. And is carbon dioxide associated with respiratory or metabolic? Respiratory, right? It's always associated with respiratory stuff. So let's say carbon dioxide is an acid and it is associated with respiratory. We are good with that? Are you with me? You understood? Okay. Two things. Carbon dioxide is an acid. It is something about respiratory. Are we okay? Good. Now, bicarb, which is HCO3, we are going to consider that as our base or alkaline. Okay. So bicarb is our alkaline or our base. Alkaline and base is the same thing. We use it. Okay. So it's alkali, it's base. Okay. Bicarb. Okay. And it is metabolic. Can you remember that? Bicarb or HCO3 is our alkaline part and it is metabolic. CO2, carbon dioxide is our acid part and it is respiratory. Bicarb is our acidic, alkaline part and that is metabolic. Got that? Are you with me? Okay. Write it down if you want to, okay? Just write it down. Now, there are two things, let's say that they work together to kind of maintain the pH level. The carbon dioxide and the bicarbonate, both of them work together to maintain the pH level. Okay, and there are two organs which help them to do that, for that working together part. One is lungs, okay, because we know the carbon dioxide is from lungs, right? So lungs will try to level off the carbon dioxide and kidneys will try to level off the bicarbonate. I don't want you to remember all the physiological functions and everything, just remember this. So what all we studied so far? Carbon dioxide is our acid part. It is respiratory. And who helps to maintain the carbon dioxide level? The lungs. Bicarbonate is our alkaline part and it is metabolic. And who is helping us to maintain the bicarbonate level? The kidneys. So the lungs, the kidneys. You good? Okay, good job. So far so good, right? Okay. Now, one more thing to remember. What are the normal values? And there is no other way. You have to study these normal values. These three. Just three. Okay? You have to remember these three. pH normal value is 7.35 to 7.45. Okay? Write it down because you are going to need this. pH value normal is 7.35 to 7.45. HCO3 normal is 22 to 28. PCO2 or carbon dioxide value is 35 to 45. Okay. Now let's see. pH is 7.35. If it is less than 7.35, it is going to be acidic. Right? If the pH is less than 7.35, it is going to be what? Acidic. If it is more than 7.45, it's going to be what? Alkaline. So less than 7.35 is acidic. More than 7.45 is alkaline. Got that? Okay. HCO3. What did we say HCO3 is? It is our alkaline stuff, right? It is our alkaline stuff. So the more the HCO3, the more the alkali, right? So it's just like pH value, right? It just goes just like pH value. The more the HCO3, the more alkaline it's going to be, because we know HCO3 is our alkaline part. It's the metabolic part, but it's the alkaline part. So more HCO3 means more alkaline. So if it is more than 28, that's going to be, if it is more than 28, that's going to be what? Alkalosis. Alkalosis, more than 28. Less than 22, acidosis. Less than 22, acidosis. Because HCO3 is our alkaline stuff, right? The more it is, the more alkaline it's going to be. So if it is more than 28, alkalosis. If it is less than 22, acidosis. Got that? Okay. Now let's come to the carbon dioxide. What do we know about the carbon dioxide? Carbon dioxide is our gas and it is our acid, right? So the more the carbon dioxide, the more acidic it's going to be, right? Because carbon dioxide is an acid. So the more the acid, more acidic it's going to be. Make sense? So the normal value is 35 to 45. So if it is more than 45, what is it going to be? More carbon dioxide. Now we know carbon dioxide is an acid. So more carbon dioxide means it's acidic, acidosis. So more than 45, if it is carbon dioxide more than 45, that means a more acid and it's going to be acidosis. Less than 35, it's going to be what? Alkalosis, right? Because more carbon dioxide, more acidosis it's going to be. So it has to be the opposite when it comes down. So if it is less than 35, it's going to be alkalosis. Got that? So that's what we are saying here. pH is less than 7.35 is acidosis. pH more than 7.45 is alkalosis. HCO3 is the alkali, right? So the more it is, more alkalosis. So more than 28, it is going to be alkalosis. Less than 22, it's going to be acidosis. PCO2, we know O2, CO2 is our acid. So the more the acid, it's going to be acidosis. The less the acid is going to be alkalosis. Got that? You sure? Okay, then we are going to the next part. Here, this is how we are going to interpret the APG using tic-tac-toe. Okay, so tic-tac-toe, do you remember how we learned, how we do the tic-tac-toe? I will try to draw here. Okay, do you remember this? We draw like this, and we put X here and 0 here. It's not really working, but then we will put X here, and then maybe we'll get another X here. Some people will do that, and we will just do that, and then we got, oh, I got the tic-tac-toe. Okay, so something like that. So this is something I just wanted you to remember. So this is what we are going to do, is like tic-tac-toe, when we say tic-tac-toe. Okay, so let me see if I can work this out. And here. Okay, so how we are going to do that? It's going to be like this. Okay, so what I was saying that when we do an ABG numbers, this is what we are going to do. But we will not cross diagonally. We can only go down. Just remember that. Okay, so we will come back to it. Okay, so let's see this. So this is how we are going to do. Now first we are going to mark like this. We are going to make it our column. This is our tic-tac-toe column. Okay, so always you write your acidic first, normal in the middle, and base or alkali. You can write base or alkali, it doesn't matter. Okay, so this is how you do your tic-tac-toe. Now I want you to write, I want you to try that with me. Okay, just two lines like this, and 2 lines across. That's all. Don't do any more. Just 2 lines this way, okay, and 2 lines the other way. That's it. See that? That's how you do the tic-tac-toe. Now the first thing I want you to write down here is acid. Okay, that's your acid. Here you are going to have your normal. Here you are going to have your alkali. Make it a pencil. Okay. So acid, normal, alkali. Can you do that? Have you done that? Have you done that? Okay, just make 2 columns across, and on top write acid, then write normal, then write alkali. That's it. This is your base setup. Okay, this is it. Okay. Now all you do after this is just put the numbers in there. Okay, so let's say for an example, we have a pH of 7.32. Now, where is our pH of 7.32 meaning? Do you remember what we talked about? Okay, let's do the normal values here once again. Okay, so that way we remember everything. Okay, let me put myself back here. Okay, let's try the normal values here. What was the pH, guys? pH normal 7.35 to 7.45, right? So the less it is acid, right? The more it is alkali, right? Okay, that's what he said. Now, what was our HCO3 levels? HCO3, we said it is 22 to 28, right? So the less it is, we will say it is acidosis. So the more it is, we will say it is alkalosis, right? Are we okay with that? Because HCO3 is an alkali. Now, what was our PCO2 levels? We said it is 35 to 45, and we said the more it is, because carbon dioxide is, we considered it as an acid, we said the more it is going to be acidosis, and the less it is going to be alkalosis. Okay, you have to remember that. Okay, now we have a question here, and what was our numbers here? pH of 7.32. Now let's go back and put that pH of 7.32. So 7.32, is that going to be acid or alkali? See, 7.35 is the normal. So if it is less than 7.35, it is going to be acid, right? Acid. So 7.32 is our value, so it's going to be acid. So we are going to write pH under the acid. Now don't write the number there. I want you to write the person's name. Okay, so you write the pH there, not 7.32. You write pH because it is acid. You got it? 7.35 to 7.45 is the normal. Anything less than 7.35 is going to be acid. So 7.32 is our value, and that is an acid. So we are going to write pH under acid. You got it? Okay. Now let's see the other one. What is our the next step? PCO2. See the PCO2, it is 48. PCO2 is 48. So let's go back and write our PCO2 here because it says 48. So PCO2 of 48. Now the PCO2 normal is what? 35 to 45. So 48 is more or less? It is more, right? 48 is more than 45. So it's more. What do we know about carbon dioxide? We said carbon dioxide is our acid. We are going to consider carbon dioxide as an acid. So if we have more acid, which is 48, more than 45, right? So we are going to have what? Acidosis, because there is more acid. So acidosis. So PCO2, where are we going to write? Under acid, right? So we are going to write PCO2 here. Okay, let's keep it like that. Now we have one more thing to look at, that is HCO3. HCO3. Now what is HCO3? It is our alkali, right? It is our alkali. The more it is, more alkalosis is going to be. So our number is 29. Okay, our number is 29. So we know it is more than 28, which is normal is 28. So 29 is more than that. So it's going to be what? Acid or alkali? Alkali. So it's going to be more alkalosis. So where am I going to write my HCO3? Just underneath my alkali. Did I get my tic-tac-toe? Now, when I get my tic-tac-toe, I have to include this heading too. Okay, I have to include that heading too. So see, if I see, I get my tic-tac-toe like this. See, oh, I got 3. 3 in a row. Tic-tac-toe, 3 in a row. Now remember, okay, remember, don't cross over like that. Okay, you don't do diagonal here. Okay, you will only do downwards. Okay, only do downwards. So this is my tic-tac-toe, which means it is acidosis, right? Which part is my tic-tac-toe? Is it is in the acidosis. So I would say this is acidosis. Now, what acidosis? Is it a respiratory acidosis or a metabolic acidosis? Who is there with my tic-tac-toe? Is it respiratory there or metabolic there? It is the respiratory there, right? It is the PCO2 which is here. So it is respiratory acidosis. You got it? Okay. See, that was easy, right? You just write down, you just make these columns. You just write down acid, normal, alkali, and you just figure out where they are in the normal values, and you just write them down and do your tic-tac-toe. Whichever ones 3 you get, that is the condition. So this is acidosis, and because there is carbon dioxide here, and we know carbon dioxide has to do with something respiratory, we would say it's a respiratory acidosis. Simple? Got it? Okay, let's do some examples here. So, let's do some examples. Ooh, that's a lot of them, right? But you're okay with it, right?